So in this question, find the relation in acceleration of the three masses as shown in the figure. So here we have three masses A, B, C, each having acceleration of A1, A2 and A3 respectively, and we are supposed to find out what will be the relationship between these three. So in this case, we are going to use to consider the theorem which is called as the work energy theorem. So making use of work energy theorem, which states that work done by internal forces is always zero. We can say that work done by the internal forces is always zero. So in this particular case, okay, so we can say in this particular case, tension is the internal force. Tension T is the internal force. So therefore work done by it will be zero. So in this case, we can say that for the A object, tension T is acting in upward direction. So this is the same string. So here also T will be acting in the upward direction, and here we will get a summation of T and 2T. So this will be 2T, and the same string, this will be also coming as 2T, and we can define this value also as T. Okay, and this will be also 2T. This will be coming as 2T, and this will be also 2T. You can clearly see that we have more or less defined the tension at on each string. Basically there are two strings, so we can say this is string number 1 and this is string number 2. So entire string number 1 is having the same tension, that is T, and the string number 2 is also having a same tension, that is 2T. Okay, so we can say that now we consider each mass individually. So we can say for mass A, we have this is mass A. It is having tension T in upward direction and acceleration A1 in the downward direction, and we assume that there is a marginal change in the distance which is called dx1. Okay, so now we can consider mass B. So for mass B mass, it is having a tension 2T in upward direction, acceleration A2 in the downward direction, and in this case also we assume that there is a marginal displacement dx2 in upward direction. And finally for mass C, this is mass C, and it is having a tension of 2t, acceleration a3 in the downward direction, and we consider that there is a marginal displacement in the upward direction, that is dx3. So according to work energy theorem, the summation of the work done in the entire system will be equal to 0. So it means work done by A. So we can say that according to work energy theorem, work done by A plus work done by B plus work done by C will be equal to 0. And if we substitute the respective things, we get T dx1 plus 2T dx2 plus 2T dx3 is equal to 0. So this equation can be simplified as dx1 plus 2 dx2 plus 2 dx3 is equal to 0. Now if we are going to find out the relationship of the acceleration, so this is the equation of the distance, a displacement. So if we take the double derivative of this equation, let us call this equation number 1, we are ultimately going to get a equation for the acceleration. So we write taking double derivative of equation 1, this will be equal to dx1 upon dt square plus 2 double derivative of x2 plus double derivative of x3 is equal to 0. Now we are going to replace the respective value of acceleration in place of double derivative of x1, x2 as well as x3, but considering the sign also. So in the figure we can clearly see that acceleration or displacement we have taken in the opposite direction. So because of that we are going to consider the negative signs. We can write it here, but acceleration and displacement are in opposite direction, thus we have minus of a1 minus of 2a2 and minus of 2a3 is equal to 0. Now taking minus as common, this we can written as a1 plus 2a2 plus 2a3 is equal to 0. So this is the final relationship between the acceleration of individual masses. No doubt this question will be also solved by using the standard procedure, which states that if you consider that A moves by a distance x and subsequently calculating all the distances, but that approach will be a lengthy one. This work energy theorem is more or less a shortcut method with the help of which we can find out the relationship between the acceleration, and if we are required to find out the relationship of the velocity, we can simply take the single derivative of the distance equation, and that will be giving us a equation or relationship between the velocity. Okay. Thank you.